Here is an example to demonstrate how the geometric vectors can be added. And we will use triangle law of vector addition, which we learned in the last video, to do vector addition. So here we are given two vectors A and B. So given vectors A and B, and we need to find these three things. Draw the vector A plus B, draw the vector B plus A, and show that A plus B equals to B plus A. So that is commutative property of addition. So whether you have A plus B or B plus A, you get the same result. So we'll show you that with this example. Now, as we learned in the last video, triangle law of vector addition says that the vectors being added should be arranged sequentially, right? From head to tail. Then the vector from tail of the first to the head of the last, which is the second here, will give us some of the vectors, right? So let's place them head to tail. So we have vector A and we need to add vector B. So let me redraw it. So vector A, this is my vector A, and that is vector B. So we'll place this tail on this head and then complete a triangle. So this is vector B. Let me bring it like this. That is vector B for us, correct? Well, when you do in your test, use your ruler, the scale, and protractor to draw parallel lines of same length, right? Now what is A plus B? A plus B is from the tail of A, right, to the head of B, right? So that line gives us A plus B. So this is what A plus B is for us. So that gives us A plus B, right? So this is vector A plus B. Now let's find how to do B plus A. Now to do B plus A, what we will do is, we will first draw this line, B, right, from tail to head, and then place A, tail of head, on the head of B, right? So let's do it. So we'll draw B first, B plus A now we are doing, right? So we'll draw B first. That's B, right? And then A. So A is like this. Let's say A is like this. A, right? So we got this A now. So B plus A is this line joining them, right? So if I join it like this, I get B plus A. If you draw them accurately, you will find that these two lines are parallel and of equal length, right? So as you can see, A plus B is equal to B plus A, and we call this commutative property of addition in vectors, okay? But remember one thing, whenever you're using triangle law of vector addition, you have to place the vectors head to tail, right? So take the first vector and then put the tail of the next on it and extend. Using this property, you can actually add more than two vectors, right? First add two and then third. For example, if we have vector C here like this, let's say this is my vector C, then it could be extended. So we have A plus B already. Now we can add C to it, right? So this is A plus B. Now if I add C here, draw a line parallel, then I get A plus B plus C. Do you see that? So that's how we can add many vectors using triangle law of vector addition, correct? And the net result will be the tail of the first to the head of the last. That is going to be the sum of all the geometric vectors added using triangle law of vector addition. I hope you understand now how to apply the triangle law of vector addition. Now we'll move on to another law, which is parallelogram law of vector addition. So we'll explain that and have followed by an example. So with that, you'll be in a good position to do vector addition using geometric vectors, right? Thank you and all the best.